After having discussed utility functions as the first important element for the analysis of consumer behavior later, we come now to the second important element, the budget constraint. While the utility functions and indifference curves and so on describe the preferences of consumers, so how much they like the different goods, the budget constraint now describes how feasible the different consumption goods are for the given income of the consumer. Mathematically, it can be written as the sum over the price of the different goods I multiplied by the amount of consumption of the different goods I. So that's the total amount of money that a consumer spends, the price times the amount of consumption, and then summed over all the goods. And that must not exceed income. So the consumer cannot buy more of the goods so that they cost more than the income that the consumer has. So the total amount spent on all goods must not exceed income. That's the constraint that the consumer faces, the budget constraint. And within that budget, the consumer can allocate its income in a way that it maximizes utility or kind of fulfills the preferences in the best possible way. Let's illustrate the budget constraint again with two goods, as we did before with the utility function, where we assume again that x1 refers to apples and x2 to bananas, where the price of apples is 1 and that one of bananas is 2, and income would be equal to 30. Then the budget constraint that we have here for n goods, in the two goods case, it would amount to p1x1 plus p2x2 is less than or equal to income. So all that I spend on the consumption of apples plus all that I spend on the consumption of bananas must not exceed the 30 units here. So we can plug in the prices. So we would get 1 times x1, so the price times the amount of apples that I consume, plus the price of bananas times the amount of bananas. That must not exceed income, which is 30. What we then see immediately is that the consumer could buy, for example, 30 apples and no bananas. So if x2 is equal to 0, then the consumer could buy 30 units of apples or 30 apples. Or we could have a situation where the consumer buys 15 bananas and no apples. So then the budget constraint would still be fulfilled with equality. Or with 10 apples and 10 bananas, it would also work. Technically, the consumer could also leave some money over so that not everything is spent. But in most of the applications, consuming more is better, which you recall from the monotonicity of preferences. So one would not leave money at the table if you can still consume goods and this delivers additional utility. So we have no dynamic situation here where you could buy additional goods in the future if you leave money over. It would just be that you don't use your total budget, although you could spend more and this would increase utility. So in this case, households would usually not be in a situation at the optimum in which money is left over. So we can write the budget constraint with an equality sign in general. And that's what we do here. Now let's illustrate this graphically. So we have here the good x1, which is apples on the horizontal axis, good x2, bananas on the vertical axis. And we've said that we could, for example, buy 30 apples and 0 bananas with the budget that we have. So we have the red point here that would be feasible. On the other hand, we could also buy 15 bananas and no apples, so this point would also be feasible. And then the budget constraint is nothing else than the connection of these 2 points, where along this line we would also have this consumption level of 10 apples and 10 bananas. So if we draw this line here, we have the budget constraint. Along this line, the budget constraint holds with equality, and all the consumption bundles drawn along this line, they are feasible with the given budget that we have. Also, all the points in the set below the budget constraint, they would be affordable, but these would be the points for which the budget constraint holds with a strict inequality. And as I've said before, as long as we assume that utility always increases with an increasing amount of consumption, and we don't have a dynamic situation where budget left over today can be used for consumption tomorrow, as long as we don't have this situation, then we would never choose a point within this set, but along the curve, as long as this is possible. The points here to the right of the curve, so further away from the origin, they are not affordable with a given budget of the consumer. And the slope of the budget line here is -1/2, because we can kind of sacrifice 2 apples in order to be able to buy 1 more banana. So we have -1/2 the slope of this budget line here. A few useful definitions can be derived from the budget constraint. I repeat the budget constraint here for the sake of convenience, which is P1 times X1, so what I spend in terms of the price on the amount of consumption of good 1, plus the price of good 2 times the amount of consumption of good 2, that needs to be equal to income according to the budget constraint. If I divide the whole constraint by P1, then I would get income on the right hand side divided by P1, which would be the real income measured in terms of good 1. I could also divide by P2 instead, then I would get on the right hand side the real income measured in terms of good 2, in this case of our example, bananas. And usually one can always normalize one price to 1, and all the n-1 other prices in the economy would then be measured relative to the good for which I have normalized the price to 1. That's Walras' law. Then the ratio of P1 to P2 would be the relative price of good 1 in terms of good 2, and it actually has an opportunity cost type of interpretation. It measures, in our case, how many bananas I would have to forego to get 1 more apple. So you can express the relative price as kind of an opportunity cost argument where you can substitute consumption of one good by foregoing the other according to the budget that you have available now, as compared to the preferences which we have done with the marginal rate of substitution, as we've seen before. Now let's illustrate what happens to the budget constraint when we have an income change. So we have the budget constraint as before, and now, for example, we get a pay rise. What would happen is the budget constraint would shift outwards. We have more available income, and that means we can buy more of both goods. In this case, we could buy 20 bananas and 40 apples because of the income rise that we had. So the budget constraint for an income rise shifts outwards. For an income fall, the opposite would be true. An income fall could be, for example, if we retire and then the pension payments are lower than the income we earned before. Then what would happen is the budget constraint would shift towards the origin. In this case, we could only afford 10 bananas and 20 apples anymore, so the falling income would shift the budget constraint to the left. What happens instead if there is a price change? We can also illustrate this here. In this case, we would have a falling price for apples, while the price of bananas stays constant. In this case, the budget constraint would shift clockwise around this point here, the intersection, which denotes the number of apples that we can buy. So in this case, we can then afford more bananas, basically, because their price has fallen. When the price increases, by contrast, then we would have a counterclockwise shift of the budget constraint around the consumption point of apples if the price of apples stays constant. So then we would have a decrease here, and we could buy fewer bananas with the given budget that we have. So to summarize, the budget constraint is the second important ingredient that we need in order to solve for the behavior of consumers and then consumer demand. So together with the utility function, the budget constraint then is the side constraint that we can set up for a utility maximization problem where the outcome then is a demand function. The budget constraint describes the affordable combinations of consumption bundles for a certain given income level. All the consumption bundles along the budget constraint and to the left they are affordable, and to the right they are not affordable. A changing income level would imply a shift of the budget constraint. If income is rising, then it's an outward shift. If income is falling, it's an inward shift. And a changing price of one good, if the other good's price stays constant, would be a rotation of the budget constraint. Thank you very much for watching the video, and I hope you found it interesting and useful. For more videos on economic content, please visit my channel that you find here to the left. And to the right, you see the next video in the series at the top, and at the bottom, you see the whole lecture in the form of a playlist.